Hi, my name is Kyle Tobias, and this is my report on regenerative braking in brushless DC motor-powered automobiles. What is regenerative braking? Well, it's a method of recapturing kinetic energy from a moving vehicle and storing it back in the vehicle's batteries. The brushless DC motors are the most common type of motors used in EVs today, so I'm going to be focusing specifically on those. They operate by manipulating a rotating EMF with electromagnets. When the EMF in a motor is reversed, it becomes a generator. So by using momentum to rotate the motors, the current normally powering the motor can be used to recharge the battery. How does regenerative braking work? So the brushless DC motor consists of two parts. We have the rotor, which contains permanent magnets and rotates. That's connected to the wheels, and the stator, which contains windings that carry the current and acts as electromagnets. And that's connected to the chassis. So the electromagnets in the stator are activated by high-power transistors in the controller, and when the motor torque opposes velocity, energy can be recovered to charge the battery. So the torque here in Q1 is produced from the battery sending current to the motors, and as you can see, the more velocity that the car has, the more torque is required when going up this little hill. And in Q2, since the car is going downhill, it's got a negative torque because the force that's moving the car is gravity rather than the current from the batteries. So in this graph, we have the back EMF versus torque or current. To recover energy with regenerative braking, you need a back EMF. And a back EMF is basically just a voltage that opposes what's causing the motion in the motor. So in this instance, what would be causing motion in the motor is the kinetic energy of the car and the wheel spinning the motor itself. So outside of the regeneration space, the vehicle must expend energy, but inside it's able to recover energy because we're reclaiming the kinetic energy in the wheels and the car has in its momentum. When the system hasn't reached steady state, regeneration is possible anywhere in the range of operation. And as you can see, we have these areas that are green, that are regeneration space. Outside, there's either no regeneration or braking, and that would be where the car accelerates off of battery power. And in dynamic braking, the motors are actually using more energy to put on the brakes than they can recover. So what are the benefits of regenerative braking? Well, brake wear is reduced, driving range can increase, and you're reclaiming energy that would otherwise be wasted. So thank you very much. Here are my references.